Multiplying, dividing rational expressions really is about just keeping track of times on top, divide on bottom. So really when we look at multiplication of fractions, really there's just a top and a bottom, and they're all combined by multiplication. So top times top, bottom times bottom really is the general rule, but we want to simplify and cancel out any times that matches a divide. So we want to factor. Okay, so when I factor, I'm going to write this as in terms of prime factors. We don't always need to prime factorize, but when I take a look at this fraction here, really there's really only one fraction. All the times go on top, so 2 times 2 times 3 is my 12. The 30 just becomes 3 times 2 times 5. Okay, now we could keep them separate if you like. You can group them into, this is my 12 and this is my 30. But since this is a fraction and we're multiplying, it's all just one big fraction. In the denominator, we end up with 5 times 5 and 2 times 2 times 2. Again, we don't necessarily need to prime factorize if we can recognize common factors. And we don't need to keep these separate at all because it's all just one big fraction with times on top, divide on bottom. So really what I'm looking for are common factors, a times and a divide that'll cancel out. A times and a divide that undo each other. A times and a divide that undo each other. Here I've got a times and divide that undo each other. Okay? So once I have that, I'm just going to rewrite this. So I have 3 times 3 on top. That's all the factors that are left, and I only have a 5 on bottom. So this ends up being 9 over 4. But the main idea is that we want to identify the factors involved here that will cancel out. Okay, so when I rewrite this, again, I don't really have to think of this as two separate fractions. It's all connected by times, and since fractions are times and divided, it's all just one big fraction. So I have times 2 times 11 times 3 times 2 on top. Those are all my times factors on top. On the bottom, I have 3 times 3 is 9, times 5 is my 45. I have my times 3 times 11 to give me my 33. So all my divide factors are on bottom, all my times factors are on top. I know that at times 11, divide by 11 will undo each other. At times 3, divide by 3 undo each other. And it looks like that's it. So that what I'm left with then is 2 times 2 in the numerator. In the denominator, I'm left with 3 times 3 times 5. Okay, so we can show that as 4 over 45. Okay. Same thing here. We want to write this in terms of its common factor. So I'm just going to write this as 4 times 5 because I can see there's a factor of 4 here. This is 4 times 7. Here's a 3 times 7, and this is a 2 times 4. Okay, I probably should have factored one of these 4s into 2 times 2, but that's okay. Once I have my times and divide all in the right spots, I can start canceling out factors. Okay, so I have 20 over 6, but this 4 and 2 can cancel out, and so I'm left with a 2 on top. So my simplified version of this is going to be 10 over, and the only factor that's left on the bottom is 3. Even with variable pieces, we just need to recognize the factors that will cancel out. So the numerical factors, I've got 2 and 2, 7 and 7. So I'm going to write this as 2 times 2 times x times 7 times 10 times, oh, there's a y in there as well. I've missed the y factor. Y times 7 times 10 times another y factor. Okay, so I have 7 times 7, and I'm going to write that just as y times y cubed, because I can see that those two cancel out. I've got a 2x times x squared, because I can see that that x will cancel with that one, and I've got the y here, which will cancel with the one on top. Now it starts to get a lot of factors here, so we have to be very organized to keep track of everything. So I've got a 2 times 7 divides 7. Looks like I have y and a y, y and a y. Now I'm going to just simplify this, rewrite this just to make sure that I've got all my things accounted for, because it's starting to get a bit messy here. And see if there's anything left to cancel. Well, I've got my x's here. I forgot that one x. Okay, so I can do it, doesn't matter, I can still do it in steps. So I still have this x factor to cancel. And it looks like at this point there's no more common factors, so I'm going to write my final answer. I'm just left with 20 on top, 7x squared y cubed on bottom. Okay, and again, I'm just looking for common factors of times and divide. Although with multiplication, really it's just a numerator and denominator that we have to work with. So, what about division? So if I have a 1/2 divided by 1/8, what does it really mean? Okay, what it means is that we're trying to see how many 1/8 fractions fit into 1/2. So how many 1/8 fractions fit into 1/2? Well, it's going to be 4 whole parts. Okay, or in other words, what we can think of this is, we can think of division as a ratio of 4 parts to 1 part, which equals 4 wholes. Okay, or 4 to 1. An easier way to do this would be since fractions are times and divide, if I'm saying this is divide, this really means that I'm dividing by 1 and I'm dividing by 8, or really multiplying by 8. If I do an opposite times, so if I do 1/2 and do the opposite, instead of doing divide I can do times, I can account for that opposite by doing another opposite, which is switching the times and divide on that second fraction. So I end up with 8/2, which is our answer of 4. So 1/2 divided by 1/8 means that 4 1/8 pieces fit into there, or we can show this as 4 when we use our times and divide strategy of just flipping our fraction, changing it to times and flipping our fraction. Really all this is doing is getting the times and divide in the right spots. Times on top, divide on bottom. Okay, so what's the rule for division? We can multiply by the reciprocal. Now we have to be a bit careful when we do this, because what we didn't do in any of these problems is we didn't state non-permissible values. Okay? And really this is the only one we need to state non-permissible values. So when we state non-permissible values, we have to remember that we are actually dividing by 1 and we're also dividing by 8 at some point. Okay? Although the 8 ends up being multiplication, it wasn't a division statement, so we have to worry about that being a 0. So we'll look at that. We'll make sure that we account for that when we state our non-permissible values.